Hello dear friends, this is Devashish and I welcome you all to my channel Statistics Curiosity. Friends, today we will see the Central Limit Theorem and we will completely prove it by the easiest manner as possible. We will see its step by step complete proof. Okay, so the video will be a little bit lengthy, so to study it completely, to understand the proof completely, please go through the entire video. Okay, let's start the video. First of all, let's see the central limit theorem's statement. What is the statement of central limit theorem? Let x1 x2 up to xn is a random sample. Okay, it is a random sample drawn from any distribution. This is the important thing. I have not said that the random sample is coming from any particular distribution, say normal distribution or some Poisson distribution or some exponential distribution or anything else. It is written that a random sample is drawn from any distribution, okay, with mean mu. Remember, the mean being mu is not somehow connected with a normal distribution. Mean mu means I have given it a name mu. Okay, so any distribution with mean mu and variance sigma square. You can use any notation, say A or B. Okay, now according to the central limit theorem, for large size n, n being the random sample size, okay, for large n means n tends to infinity, okay, but the central limit theorem holds good for n greater than 30. So in general, when n is greater than or equal to 30, we consider it as a large sample size. Okay, so for large n, the distribution of I must say the sampling distribution of sample mean x bar. Okay, the sampling distribution of sample mean x bar approaches to normal distribution. Okay, approaches to normal distribution with mean mu x bar is equals to mu, which is the mean of parent population, and standard deviation sigma x bar is equals to sigma divided by under root n. Okay, where sigma is the standard deviation of parent population. So the importance of central limit theorem is basically is that we do not know the distribution of population. We do not have any knowledge about population. Okay, we just have its mean and variance, but we do not know the parametric form of population. We do not know whether it is normal, whether it is exponential or anything. But for large size n, the distribution of sample mean will be normal distribution. Normal, or it is also called Gaussian distribution. It is also called sometimes a bell-shaped distribution because it is symmetric in nature. Okay, symmetric in shape. Okay, so this is in simple terms we can say, when x following any distribution with mean say mu and variance say sigma square, then the distribution of x bar for large n, okay, distribution of x bar will be normal with mean mu and variance sigma square divided by n. Okay, this is the statement of central limit theorem. Now we will see its proof. For its proof, first we will write the moment generating function. Okay, we know the moment generating function, in short it is termed as MGF. Okay, the moment generating function of x we all know is mxt. Okay, and it is nothing but expectation e raised to the power tx. Okay, now if we want to write as we want to know the distribution of x bar, so the mx bar t, moment generating function of x bar. So as mxt is expectation e raised to the power tx, then mx bar t will be expectation e raised to the power tx bar. Okay, now e raised to the power t multiply x bar. X bar we all know sample mean is summation xi divided by n, where xi is the random sample. Okay, xi is the random sample. Okay, so summation xi divided by n. Okay, now we can open this summation xi as x1 plus x2 plus up to dot 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 xn. Okay, then what will happen? Expectation e raised to the power t by n x1, okay, into e raised to the power t by n x2 up to e raised to the power t by n xn. Okay, since summation xi is x1 plus x2 plus up to xn, we can open it as e raised to the power t by n x1. Now we all know x1 x2 up to xn is a random sample. As it is a random sample, so the xi's must be independent, and when xi's must be independent, we all know if x and y is independent, then expectation of xy is expectation x multiply expectation y. So the expectation of all these terms, we can write these terms individually. Okay, expectation of e raised to the power t by n xn x1 t by n x2 up to expectation e raised to the power t by n xn. Okay, since all these x1 x2 xn belongs to single population x, so these all terms we can write it as mx1 t by n, mx2 t by n, okay, up to mxn t by n. Since we all know these all xi's are coming from the distribution x, okay, the population x, so each of these values will be same as mx t by n, okay, mx t by n up to mx t by n. So we can write it as mx t by n raised to the power n. Okay, now so we have a formula here, mx bar t is equals to mx t by n raised to the power n. We can write it as equation 1. Now what we will do, we will define a new variable, z, that is equals to x bar minus mu divided by sigma divided by square root of n. Okay, we will define this a new random variable z as z. Okay, since we do not know the distribution of x, so we cannot substitute the moment generating function of x here. We cannot basically extend this equation 1. So we will define a new random variable z and try to find out the distribution of this z, and the distribution of this z will help us to find the distribution of x bar. Okay, now so defining a new random variable z, now we will write what? Moment generating function of z. Okay, so the as we all know, the moment generating function of x is expectation e raised to the power tx. So the moment generating function of z will be mzt, and that will be expectation e raised to the power tz. Now we will substitute the value of z, expectation e raised to the power t x bar minus mu divided by sigma divided by square root of n. Okay, but now taking every constant value outside the expectation e raised to the power t, let's see, e raised to the power t x bar divided by sigma under root n, that will be the first term. There will be two terms, e raised to the power t into x bar divided by square root of sigma divided by under root n, and e raised to the power t multiply mu divided by sigma under root n. So the e raised to the power t multiply minus mu divided by sigma under root n, this term will be constant. So we will keep this term outside the expectation. We all know expectation ax is a expectation x. Okay, so that a can be written as outside the expected value. So we can write e raised to the power t minus this minus mu divided by sigma under root n, and inside expectation there will be e raised to the power t x bar divided by sigma divided by under root n. Okay, now we can write it as, we can take this under root n in the numerator, we can write it minus t mu under root n divided by sigma expectation e raised to the power t x bar under root n divided by sigma. Okay, now what we can do, we can write this term as mzt equals to e raised to the power minus t mu square root of n divided by sigma. We can write this term as, we all know mxt is equals to expectation e raised to the power tx. So we can write this expectation e raised to the power t under root n divided by sigma x bar. This x bar will be treated as x. We can write it as mx bar t under root n divided by sigma. Okay, we can write this. Okay, now using equation 1, we have proved that equation 1 earlier. What it is telling us? It is telling us if we want to write the moment ending function of x bar in terms of x, what we can do? We can divide this t by n. We can divide this t by n and take whole power n. Okay, we will divide t by n and take whole power n to convert this x bar into x. Okay, so to convert this x bar into x, what we will do? To convert this x bar into x, what will we do? We will divide this entire term by n and take whole power n. Okay, now we can write it as e raised to the power minus t mu square root of n divided by sigma, and now this x bar is converted into x. Mx t divided by sigma under root n, this root n will be cancelled by this n, whole power n. Okay, we got this term using equation, we can write it using equation 1. Okay, from 1. Okay, now we can write this entire term as equation 2 now. Okay, now we will take log both sides. Now let's see, by taking log both sides, it will be log mzt. This log will be will cancel that e. Okay, it is basically a natural log, so that will be minus t mu square root of n divided by sigma, and we all know log x raised to the power n log x. So this n will be written as and the by log of multiply of two terms is log of a plus log of b. Okay, so the log of this term is this, plus log of this term is n log this entire term. What this entire term is? This is log mx t by sigma under root n. Now note that we all know mxt is expectation e raised to the power tx, and we can write this e raised to the power tx by expanding this it as 1 plus tx. We all know the expectation of e raised to the power x, 1 plus x square divided by 2 factorial and so on. So 1 plus tx plus t square x square divided by 2 factorial plus and so on. And this will be expectation of 1 is 1, expectation of tx is t expectation of x, expectation of this is t square divided by 2 expectation of x square, okay, and so on. We all know mu r dash, rth moment about origin, is expectation x raised to the power r. So mu 1 dash will be expectation x, mu 2 dash will be expectation x square and so on. So we can write it as x1 plus t mu 1 dash plus t square divided by 2 factorial mu 2 dash and so on. Now what we will do, we will substitute the value of mxt, this value of mxt, in equation 2. We will substitute this value of mxt, you can write this as equation 3. We will substitute the value of moment generating function mxt from 3 in 2, okay. So from 3 we have mxt is 1 plus t mu 1 dash plus t square divided by 2 factorial mu 2 dash and so on. And equation 2 is mzt, this is I think I should write this as equation 2, not this, okay. I should write this as equation 2. So what we will do, I will substitute this value mxt 1 plus t mu 1 dash plus t square divided by 2 factorial mu 2 dash and so on. I will substitute this value in this equation here, okay. So what is happening, mxt is 1 plus t mu 1 dash plus t square divided by 2 factorial mu 2 dash. What is happening here, mxt divided by sigma under root n. So what we will substitute it, 1 plus t divided by sigma square root of n mu 1 dash plus t square divided by divided by sigma square n mu 2 dash and so on, okay. So what we will do, we will substitute this value by taking t divided by sigma under root n, at place of t, okay. So what we will get, log mzt is equals to minus t mu square root of n divided by sigma plus n log mxt divided by sigma under root n. So that will be 1 plus, what will be t at place of t, we will put at place of t divided by sigma under root n. So that will be 1 plus t divided by sigma under root n mu 1 dash Now what we will get, 1 plus t divided by sigma under root n mu 1 dash plus t square divided by sigma square n mu 2 dash, okay, t square divided by sigma square n mu 2 dash plus and so on, okay. Now we all know what is the value of log 1 plus x. We all know what log plus 1 plus x is. Log 1 plus x is x minus 1 by 2 x square plus 1 by 3 x raised to the power 3 and so on. Okay, we all know this. So what we will do, we will expand this log 1 plus and take this this term as x. What we will do, we will expand this log 1 plus this entire x. So what we will get, minus t mu square root of n divided by sigma plus n log 1 plus x. Log 1 plus x. What we will get? We will get log 1 plus x. First of all, x. That means this entire term. T divided by sigma square root of n mu 1 dash plus t square sigma square n mu 2 dash and so on, this entire term. And next term will be minus 1 by 2 square of this entire term. What is this? Log 1 plus x. X minus 1 by 2 x square. Square of this entire term. T divided by sigma under root n mu 1 dash plus t square sigma square into n mu 2 dash so on, square of this. Okay, plus 1 by 3 and so on. Okay, now what we will do, since we can extend this using many terms, what we will do, we will only write those terms that will not have n or any power of n in the denominator. As we know, we have to take limit n tends to infinity because the central limit theorem is the limiting property. Okay, so what will happen then? All the terms containing n in the denominator will go to 0. Okay, so what we will do, we will only take those terms that do not have n in the denominator, or the term containing n will cancel out in the denominator as well as in numerator. Okay, so we will only take those terms. So minus t mu square root of n divided by sigma plus n multiply by this term. N, what we will do, that this square root of n will be divided by this n and we will get square root of n, multiply t, multiply mu. You should know mu 1 dash is nothing but mu because it is expectation of x. Okay, and we know that the mean of population is mu. Okay, so t square root of n into mu 1 dash divided by sigma. What will be the next term? This n will be multiplied by this, and so n and both n will be cancel out each other. So what will be the next term? T square divided by sigma square mu 2 dash. T square divided by sigma square mu 2 dash. Okay, then we will not write other terms because those term will, what will be the next term? The next term will be t raised to the power 3 divided by sigma square, okay, n square, and then by cancelling single n with that n, we will still have an n in the denominator, so we will not write those terms. So only writing these two terms, minus 1 by 2, we all know a plus b whole square. What is that? A square plus b square plus c square plus 2ab plus 2bc and so on. But what we have to do, we only have to write that term that do not contain n. So the square of first term will be t square divided by sigma square. Square root of n square is n mu 1 dash square. Okay, and every other term excluding this term and this term. Excluding these three terms, every other term will contain n in its denominator. So what we will do? We will not write those terms. What we will do? We will write all those terms as order of 1 by n. All those terms as order of 1 by n. Okay. These two terms cancel out each other. What we will have? We will only have t square divided by sigma square, t square divided by sigma square, mu 2 dash minus, we also have we should also have 2 factorial here. From this equations 3, t square divided by 2 factorial, we also have 2 factorial. So that 2 factorial will be also be written as 2 in its denominator. This 2 will also be there in this term. Okay, now what we will do? We will take this 1 by 2 and 1 by 2 from both these terms and t square and divided by sigma square. T square divided by 2 sigma square, from both these terms we will take these terms as common, t square divided by 2 sigma square. And what we will have? We will then have mu 2 dash minus mu 1 dash square plus order of 1 by n. Okay, now we all know mu 2 dash minus mu 1 dash square, expectation x square minus expectation x whole square. What is this? This is variance of x. And what is variance of x? Variance of x is sigma square in this theorem. We already have assumed this. Multiply sigma square plus order of 1 by n. Then what we will get? We will get sigma square will cancel out by sigma square. It will be t square divided by 2 plus order of 1 by n. This entire is equals to what? Log mzt. Now what we have derived? Log mzt is equals to t square divided by 2 plus order of 1 by n. Okay. We have log mzt equals to t square divided by 2 plus o 1 by n. Now we will take limit n tends to infinity for this term. So by taking limit n tends to infinity, we will know that order of 1 by n will become 0. All terms containing n in the denominator will become 0. That's why we have not taken that values earlier. Okay. So this term will become 0. We only have t square divided by 2 on the right hand side. Now we can clearly see that mzt will be e raised to the power t square by 2 by taking this log at the right hand side. Now what e raised to the power t by 2 is resembling with? We all know that the distribution of, if the distribution of x following normal distribution, then what is the moment generating function of normal distribution? You should have remember this. The normal distribution, a moment generating function of normal distribution is e raised to the power mu t plus half t square sigma square. Now putting mu as 0, sigma square as 1, we all know that this is standard normal variate. So the moment generating function of standard normal variate will become e raised to the power, this mu becomes 0, so we only have e raised to the power 1 by 2 t square. We can clearly see this is e raised to the power t square by 2, this is e raised to the power t square by 2. So we can clearly see that the distribution of z is normal 0, 1. Now as we already know that the distribution of x is unknown to us, this x is only for reference. In the actual theorem's statement, we do not know from where this xi's are obtained. We do not know the distribution. But what we know? We know the distribution of z. What will be the z? What is the z? Z is basically a new random variable that we have defined earlier. Okay. Now we all know that the distribution, now we achieved the result that the z following normal 0, 1. What is z? What we have defined as z? Z is x bar minus mu divided by sigma upon under root n. So we can see that we can write it as but remember we can write it as limit n tends to infinity, yani ki we can write it as for large n. What we can write it as for large n. Z following normal 0 1. We can also write it x bar minus mu divided by sigma square root of n following normal 0 1. We all know what is the mean of normal d0 1. Mean is 0 and variance of standard normal variate is 1. So the mean of x bar minus mu divided by sigma upon under root n will be 0. So from here we can see expectation of x bar will also be 0. Also variance of x bar minus mu divided by sigma under root n is 1. So we can see variance of x bar will be what? We all know the variance of any constant multiply x is a square variance of x. So this term will be square of sigma square divided by n. So that variance of x bar will be, and we also know variance of any constant is 0. So variance of mu will be 0. So we have these two results. Expectation of x bar is 0. Variance of x bar is sigma square divided by n. So not 0. Sorry. Variance of x bar is mu. Okay, not 0, it is mu. So we can clearly see as z is following normal 0 1, so x bar will also be following normal distribution with mean mu variance sigma square divided by n, and this is the result that we are looking for. Now let's summarize what central limit theorem was and how we proved it. The central limit theorem states that a random sample of size n is drawn from any distribution. We do not know the parent form of parametric form of the parent population. We only know that the mean and variance mu and sigma square of that distribution. A random sample is drawn from any distribution with mean mu and variance sigma square. Then for large n, the distribution of x bar will be normal with mean mu and variance sigma square divided by n. Now how we achieve the proof of this? The proof of this is consisting of 4 steps. What is the first step? The first step is writing the moment generating function of x bar, m x bar t. And what we get? We get m x bar t is equals to m x t divided by n whole power n, and write it as equation 1. Now what is the second step? The second step is defining a new random variable z. By defining a new random variable z as x bar minus mu divided by sigma divided by square root of n. Now what is the second step? In this second step we write the moment generating function of this z, mzt, and what we get? We get mzt as Now after defining this z, we will write the moment generating function of z and take the log of it. And after solving the log of moment generating function and after certain calculations, we will get log mzt is equals to t square divided by 2 with some terms containing n in denominator. Now taking limit n tends to infinity, this is the third step. By taking limit n tends to infinity of this log mzt, what we get? We get log mzt is equals to t square divided by 2, and mzt equals to e raised to the power t square divided by 2. And we all know what this e raised to the power t square divided by 2 is. This term is the moment generating function of normal 0 1 or standard normal variate. So what is the third step? The third steps basically derive the distribution of z as a standard normal distribution. And what is the fourth step? Fourth step is nothing but the finding the value of x bar, finding the mean and variance of x bar by using this z and the result of this z. And the mean and variance of x bar we got as expectation of x bar as mu and variance of x bar as sigma square divided by n. So this was the proof and its complete explanation, step-by-step explanation of Central Limit Theorem. I hope you enjoyed this video. I hope you understand the topic. I hope you understand the proof as well. If you have any queries, please let me know in comment section. Please like, share and subscribe my channel. Thank you for watching.